square. Solve d square plus a square. D square plus a square into y is equal to secant ax into y is equal to secant ax into y is equal to secant ax, right? So already we solved this type of problem yesterday, but in the yesterday problem we have tan ax, right? So why I am discussing one more problem is, so this type of problems are very important problems, right? So because of that one more time I am attempting the problem, same problem, right? So the particular integral is equal to, right, q of x by f of d, that is equal to secant ax by d square plus a square. So that is equal to 1 by d plus a into d minus a into secant ax. So write down it as a by d minus ai plus b by d plus ai into secant ax. So now simplify the values of a b. Now simplify the values of a b. So by using the, I am just splitting the given f of d, that means that factorizing the given f of d, right, into two factors. So and separating by using the partial differentiation concept, sorry, partial derivative concept. So here what are the values of a comma b? What are the values of a comma b? What is a?
1 by 2ai, sir.
1 by
2ai.
Yeah. What is b?
Minus 1 by 2ai.
Very good. Right. Very good. So that is 1 by 2ai. Right? 1 by d minus ai minus 1 by d plus a. 1 by d plus a. Right? Very good now. Into secant ax. So that is equal to 1 by 2ai. So this is secant ax by d minus ai minus secant ax by d plus a. Right? So likewise, yesterday problem. So we consider one term. So based on that, we just replace I by minus I. Then we will get this result, right? So consider. So this is PA. Consider secant ax by d minus a. So what it as equation number 1? D minus a. Right? Now it is of the form q of x by d minus alpha. So simplify that one. Right? So that is secant ax by d minus ai, that is equal to what na? E power aix integral e power minus aix into secant ax dx. Why? Because 1 by d minus alpha into q of x is equal to e power alpha x integral e power minus alpha x into q of x dx. So based on this part, now we have to simplify this one, then we will get the required result. That's it. So this is equal to e power ax integral. What is e power minus the I theta? So it is nothing but cos theta, that is cos ax minus I sin ax. What is secant ax? 1 by cos ax. 1 by cos ax. It is a very simple question, right? So that is equal to e power ax integral. So divide with the cos ax, then you will get 1 minus here I into tan ax. I into tan ax, right? Into dx. So that is equal to e power ax. Integral. So the integration of 1. So that is x minus I. What is the integration tan x? Tan ax. What is the integration of tan ax? What is the integration of tan ax?
Secant.
Yeah, 1 by a log not secant ax. Log not secant ax. So, right? So this is the integration to the tan ax. right? So therefore, right? So that's enough, right? It's a very very simple question, right? So therefore 1 by d minus a into secant x is equal to therefore 1 minus sorry secant x by d minus ai is equal to, right? So is equal to what the value ma e power ax into x minus I by a, x minus I by a, log mod secant ax, log mod secant ax. So similarly, so secant ax by d plus ai, what is value? Just to replace I by minus I by minus I. So కావాలని రాయండి, replace I by minus I by minus I. So you will get this is e power minus aix, this is x plus I by a log mod secant ax, log mod secant ax. So you just substitute these values from 1, right? So that is in 1. So from 1, right? So ypa is equal to 1 by 2ai, 1 by 2ai. So 1 by d minus a into secant x, it is nothing but what amma? E power ax. Are following or not ma? Everyone?
Yes, sir.
Yeah. Minus next
Yes,
one.
sir.
Minus this is e power ax x plus I by a log mod secant ax, log mod secant ax. Now how to simplify this one? Then you will get the required result, right? So that is the problem, right? So just to simplify this one, so 1 by 2a is common, right? That is equal to 1 by 2ai. So here from these two steps x is common. Take x is common. So it is nothing but e power ax minus e power minus aix. Next, from these two steps, right? So minus I by a, log of secant x is common. So what happened? What happened? So it is e power aix plus e power minus aix. Is it clear now? 1 by 2ai is common. So here I am taking the common terms, right? So x is common, so that it is e power ax minus e power minus ax. Next, here minus I by a is common into log secant ax. So here it is e power aix minus into minus. So here I am taking minus, so that it becomes plus. So is it clear to everyone?
Yes, sir.
Yeah. Now this is equal to, right? This is equal to, right? X into, right? So write out x into e power aix minus e power minus aix by 2ai by 2a. I multiply 2a inside the values, right? So here I by 2a square I, 2a square I, log of secant ax into e power ax plus e power minus ax minus ax. Now we have to simplify this one. Next, we know that e power ax minus e power minus ax is nothing but what am I? By 2a is nothing but what am I? Sin ax. Yes? Is it correct, ma? It is sin ax, that is e power ax is cos ax plus I sin ax minus cos ax plus I sin ax. So I sin ax plus I sin ax, that is power minus ax by 2y is equal to sin ax. Is it clear, ma? Yes? Is it clear to you? Sai, is it clear, ma? Sai,
Yes, sir.
right. Next, Sandhya, is it clear, ma?
Yes,
Sandhya,
sir.
right.
Yes, sir.
Very good. So therefore, next right, e power aix plus e power minus ax by 2. It is nothing but cos ax. Cos ax. So these are the known formulas. So that is known values. Just to replace there, then here e power ax minus e power minus ax by 2y is nothing but sin ax by a. Next, here I gets cancelled, right? Minus, so you put it 2 as here, right? So its value is nothing but minus 1 by a square into log mod secant ax into cos ax So this is the required particular integral. This is the required particular integral. Is it clear to you, everyone? It is a very simple question. X by a sin ax, right? So minus 1 by a square log mod secant ax, right? So into cos ax, Suppose if you want to change this one, so it becomes log x power m is equal to m log x, so that it becomes less of minus whole power 1. So 1 by secant x is, that is nothing but cos x. Suppose if you want, otherwise no need to simplify this one. So it becomes x by a sin ax plus x by a square log mod cos ax into cos ax. If you want, you can change it. That is x power, that is log x power minus 1 is equal to minus log x. That is equal to, it is also written as log 1 by x. So based on this concept, log of secant ax whole power minus 1, that is nothing but log of 1 by secant ax. In place of x we have secant ax. So 1 by secant ax is nothing but cos ax. So if you want, then you can simplify like this. Otherwise, you can stop here. There is no problem with that. So this is the problem related to the yesterday problem, right? And it is also one of the very important concept, and also one of the very easy concept. Is it clear, ma? Manisha, is it clear, ma?
Sir.
Yeah. Srivalli, is it clear, ma?
Srivalli didn't attend the class, sir.
Okay. Right. Thank you. Lalita, is it clear, ma?
Yes, sir.
Yeah. Just to practice the problem. No need to write entirely. So, right? Just to practice. So, next problem, I will give a clue. So, and I know I am not going to solve the entire problem. So, right? So, d plus 2 into d minus 1 whole square y is equal to e power minus 2x plus e power minus 2x plus e power minus plus 2 sin hx. 2 sin hx. So, as per our discussion, there is no type for solving the trigonometric functions, right? That is, if q of x is a trigonometric, that is hyperbolic function, there is no types. There is no types. But we have the types related to the sin x or cos x and tan x or secant x. So that means the trigonometric function we are solved. But we don't have any types related to this. How to change that one?
e power x
Simplify
minus
the
e power
system?
minus x by 2, sir.
Actually, directly we don't have any methods or any types related to hyperbolic functions. So how to solve this one?
Sin
E power
hx
minus
formula, sir.
x
e power
Yeah,
minus
x
e power
minus
x
by
e
by 2.
power minus x by 2.
changing hyperbolic functions into exponential functions. Why? Because we just now we are writing that is cos x and sin x values. So like that we have sin hx that is equal to e power x minus e power minus x by 2. I think 2i. Sorry. E power ix. Sorry. No. E power x minus e power minus x by 2. Next, cos hx is equal to e power x plus e power minus x by 2. So by using that concept, then you have to simplify the problem. By using that concept, then you have to simplify the problem. So is it clear, my everyone?
Yes, sir.
Now it is of what type?
Type 1.
It is of type what type?
Type 1, sir.
Yeah, type 1. So it is clearly type 1. So you just verify, right? So that means that whether the given function fails or regular case, that is failure case or regular case. So based on that idea, so you can simplify this problem. So that it becomes, the q of x becomes, so e power minus 2x plus 2 into e power x minus e power minus x by 2. So this one cancel. So here q of x is equal to e power minus 2x plus e power x minus e power x. So therefore particular integral is equal to e power minus 2x by d plus 2 into d minus 1 whole square, d minus 1 whole square plus e power x by d plus 2 into d minus 1 whole square minus e power minus x by d plus 2 into d minus 1 whole square. So we have three parts, right? So that is we are going to calculate the particular integral to the three different functions. One is e power minus 2x, and the second one is e power x, and third one is e power minus x. So just listen. I will discuss one by taking one function. So that is consider. So others you can write it as ypi1 plus ypi2 plus ypi. For our simplification, that is for our understanding purpose only, I am writing here, right? So now consider ypi1. So it is e power minus 2x by d plus 2 into d minus 1 whole square. D minus 1 whole square. So check whether it is failure or regular case.
Failure,
Failure
sir.
case.
Yeah, failure. So it is a failure. Why? Because here we have minus 2, but in case of DV, if you replace minus 2, it becomes 0. So listen carefully. So if it is failure, how many, that is the root repeated how many times? So that you observe very carefully. So here d plus 2 whole square means the root repeated two times. D plus 2 means the root repeated one time. The root repeated one time. So if root repeated one time, what happened? So we can written as x into e power minus. So in place of this, we are taking x by 1 factorial, right? 1 factorial into, so we can replace here. This is minus 2 minus 1 whole square. That is equal to x into e power minus 2x by 9. X into e power minus 2x by 9. Suppose if I am getting a confusion, then take f of d as d plus 2 into, right, d square plus 1 minus 2. And you can find the f dash of d. You can find the f dash of d, and d is equal to minus 2. D equal to 0, then you have to replace x into e power minus 2x by f dash of d value, right? And what? D is equal to 2. D is equal to 2. So that is the another way. That is the another way. But here it is it is taking some time. Why? Because we are extending the function f of d, and also it is also very easy. So and by directly we will get this value. But in this case, first we will check how many times it is repeated. One time, so that here 1 factorial occurred, right? So e power minus x, and here we have another non-zero term, that is d minus 1 whole square. So you can find this value as it is, So that is the thing, right? So and this is the another way. This is the another way. So whatever you feel easy, you can follow that one. So no problem, right? So here the formula is that is x power r by r factorial into phi of a. X power r by r factorial into phi of a. Here root is repeated one time, so that x power 1 by 1 factorial into phi of a. Phi of a means a is 2. Here what is phi of b? Phi of b is equal to d minus 1 whole square. D minus 1 whole square. That means that in f of d, so which one is non-zero at a? D is equal to a. That is called phi of d. That is called phi of d. So you can simplify in this manner also. So otherwise, we can expand the f of d. That is, we can expand the factors and make it as f of d form, and you just find out the derivative. So with respect to d, and you can substitute d by a, and you will check whether it is 0 or non-zero. Suppose if it is non-zero, so you conclude that the root is repeated one time. So now we can calculate the value of f dash of d, and d is equal to a. So and you can substitute directly in the denominator. So in the numerator, x by f dash of a, and d is equal to a. So that is the process, right? So here I am explaining two ways. So make a d is equal to, you can follow that way, no problem. So next, so coming to the second one. So here also yp8, that is equal to e power x by d plus 2, into d minus 1 whole square. So here it is a failure case or regular case?
Failure, sir.
Failure case.
So it is a failure case or regular case?
Failure case.
Yeah, if it is a failure case, the root repeated how many times here?
2 times, sir.
2 times.
Yeah, very good, 2 times. And next one more thing is, in f of d, is there any non-zero factor? When you replace d is equal to a, is there any non-zero factor?
D plus 2 is non-zero factor, sir.
Yeah, d plus 2 is the non-zero factor. So that means that is phi of d. So in this case, so first we have to apply this one. Root is repeated, so that x square 2 times by 2 factorial. So here one time, so that x by 1 factorial into e power x by, so it is a non-zero factor. In f of d, it is a non-zero factor.
Yes,
Replace,
sir.
yeah, 2x by 6. 2x by 6. Anything problem? Ma,
That x
anything
square
problem? X square?
e power x, sir.
Yeah, sorry. X square e power x. Right, very good. X square e power x. Right? So this is the way. This is the another way. Suppose if you want to simplify, that is expanding f of d. So here f of d is in a factorization form. So you can simplify that one into the polynomial form, and you can calculate the derivative, and you substitute d is equal to 1. If it is 0, then you will calculate the f double dash of d, and if it is not equal to 0, then only you can confirm the root is repeated 2 times. So therefore we have x square by f double dash of d, and d is equal to 1. So that is the another way. So it is the simple approach. So here we have two factors. one factor is 0 at d is equal to a and other factor is non-zero. So in that situation, how to solve means first we have to apply to the one factor, that is x square by 2 factorial. So this is for d minus 1 whole square into e power x by 2 plus 1. E power x by 2 plus 1, right? So that is the way. So is it clear to everyone? But suppose if anyone having doubt, then please ask me. Is it clear?
Yes, sir.
Yeah. Thank you. So next one is and y, that is the next function is ypi3. So that is the ypi3. So ypi3 is a failure case or regular case?
Regular case, sir.
Yeah, so regular case there is no problem. So you can directly substitute d by minus 1. Why? Because the coefficient in the exponential function is minus 1 e power x. So that a is equal to minus 1. Just to replace d by minus 1, then you will get the answer directly. And finally you can add these all, then you will get the required particular solution to the given differential equation. So right? So that is the problem. Next one. D cube plus 1 into y is equal to cos of 2x minus 1. Cos of 2x minus 1. Here we are going to calculate the particular integral to the given function. Right? Particular integral to the given function. So here particular integral is equal to cos of 2x minus 1 by d cube plus d cube. Just observe carefully. We are not discussing this type of problems in previous classes, but you don't get confusion. Don't get confusion. So you assume that it is of the form cos of ax plus b. So it is of type what, ma? It is of type 1 or 2 or 3 or 4 or 5 or 6. Cos ax. It is of the form cos ax.
Two, sir.
It is of type
Type 2, sir.
type 2. So we don't bother about B. Don't bother about B. It is a constant. It is a constant. Suppose in place of 1 we have 2y. So it is a problem. It is a problem. So in the situation you have to separate the cos 2x minus 2y by using cos a minus b. But here there is no problem. Why? Because here only 1 is a constant. So now here also just to replace d square by minus a square. So here what is a?
2.
2. So simply d square is equal to minus 1, right? So this is the way, that is equal to cos of 2x minus 1 by d cube plus d into d square. Why? Because wherever you have d square, then only you can substitute it by minus a square, right? So you don't touch the term d, right? So that is very, very important. That is equal to cos of 2x minus 1 by minus 4d plus 1. Minus 4d plus 1. That is equal to cos of 2x minus 1 by 1 minus 4d. 1 minus 4d. Still we have the derivative terms in the denominator. So it is not a good. We have to eliminate the denominator terms from the denominator, the derivative terms from the denominator. So, but here we have the trigonometric function in the numerator, but in the denominator we have the d terms. But we require d square term. What have to do here?
Rationalize with 1 plus 4.
I see.
What? With its reciprocal, that is 1 plus 4. 1 plus. So now we will make the term 1 minus, that is d square term in the denominator. So it becomes cos of 2x minus 1 into 1 plus 4d by 1 minus 4d square. So that is equal to cos of 2x minus 1. Multiply this one. Plus 4 into derivative of
Sir, 1 minus
2x.
16 d
16
square,
d
sir.
square,
Sir,
sir.
What?
1 minus, sir,
1 minus 16 d
1
square, sir.
minus 16 d square, sir.
What?
1
1
minus
minus
16
16
d
d
square,
square,
sir.
sir. Not 4 d square, sir.
1 minus 4d. Yeah, sorry.
1 minus 16 d square, sir.
Sorry. Yes. Yes. So here 16. D square is replaced by minus a square. Still function not changed ma. So the a square is fixed up to the end. So its value is minus 2. So therefore that is equal to cos of 2x minus 1. What is the derivative of cos? That is 4 into minus 2 into sin
Minus 2.
2x minus 2 by, so this is minus into minus plus 16 4 the 64, this is 64. This is equal to cos of 2x minus 1 minus 8 into sin of 2x minus 1 by 60. So this is the required problem, right? So here we have the d cube term, and for getting confusion, the q of x is of the form cos of 2x minus 1. So many of them getting confusion. Here what is a? But here clearly a is the coefficient of the x in the trigonometric term, right? So you have to compare with the term just like cos of ax, and you don't need to think about the constant. You don't need to think about the constant. So here a is 2. So it is of type related to the type 2. So in type 2, we just replace d square by minus a square. D square by minus a square. That's it. So it's clear to you?
Yes, sir.
Yes, sir.
Yeah, very good. So up to now, what we are discussing is, we are discussing the differential equations with having that is constant coefficients. So we have to observe that up to now, what we are discussing is the differential equation having constant coefficients. Constants means 1, 2, 3 like that. But now we have the two important methods. So that means that is Cauchy Euler's method and Legendre's method. So right. So for solving such type of methods, such type of differential equation, we have separate solution. We have separate solution. So and that differential equation having the coefficients are variable coefficients, right? The coefficients of the differential equations are variable coefficients. Up to now what we discussed, so the differential equation having the coefficients constants, Yeah. So is completed, problem completed,
Yes, sir.
Yeah. Now next one. Just a minute. Yeah. So Cauchy Euler method, right? So Cauchy Euler method. So this is also called homogeneous linear differential equation type. So this is also called homogeneous linear differential equation type. So in this unit we have that is two topics pending. So one is Cauchy Euler equation. Second one is Legendre's equation. So just observe the that is the procedure. First I will discuss the procedure how to solve the Cauchy Euler type or Legendre's equation. Just listen, right? So first one is Cauchy Euler differential equation. Cauchy Euler differential equation. It is also called as homogeneous linear differential equation. Linear differential equation. It is also called as homogeneous linear differential equation. First, So what is meant by Cauchy Euler differential equation? Means a homogeneous linear differential equation, right, consisting of the variable coefficients. So that means that the equation of the form, right? So x power n into d power n by dx power n plus x power n minus 1 into d power n minus 1 by dx power n minus 1 plus and so on plus and so on plus, right? So 1 y plus and so on plus x into dy by dx plus y is equal to 0 is equal to 0 is equal to 0. So this is called Cauchy Euler type differential equation. Cauchy Euler type differential equation. But up to now, what we are discussing is a into d power n into y by dx power n plus a minus 1 into d power n into n minus 1 by dx power n minus 1 plus and so on plus a1 into dy by dx plus a0 is equal a0 into y is equal to 0. But here the coefficients are variables. But now the coefficients are variable coefficients. So how to solve this type of differential equation means by using the transformation technique. So why we are changing one variable into another variable. That is x is the independent variable. We are changing the independent variable x into the another variable. Sir, why we are changing the independent variable means, so there is no direct process for solving such type of differential equations. Now we have to change the differential equation having the variable coefficients into the differential equation having the constant coefficients. But we have the types, but we have the very well-known formulas. So that means that for solving the differential equation with the constant coefficient. So because of that, here the first thing is, first we have to change the given differential equation that is consisting of the variable coefficients into the differential equation with the constant coefficient. So after that, after transformation into constant coefficients, we have the many methods to solve that differential equation. So it is the easy way. So this is the basic idea. For using the transformation, right? So therefore, here what we have to use is so x is equal to e power z. So it is the suitable transformation. So here I am changing the independent variable x as in terms of z. So now here what is z? Z is equal to what, ma? Log x. Z is equal to what, ma? Log x. Now dz by dx is equal to what, ma? 1 by x. dz by dx is equal to 1 by x. But here we have dy by dx, d square y by dx square, d cube y by dx cube, and so on. So now we are going to calculate the values of dy by dx. So that means that we are changing the independent variable into z. So we have the new derivatives in terms of z, that is with respect to z. So that is the process. So that is equal to as per chain rule. So it is nothing but dy by dz into dz by dx. So that is equal to dy by dx into what the value of dz by dx? 1 by x. So
1
therefore
by x.
with this x into dy by dx is equal to dy by dz. dy by dz. dy by dz. So that is x into d by dx is equal to d by dz. d by dz for every y. So is it clear up to this? So x into dy by dx is the value is equal to dy by dz. dy by dz. How we apply this one means by using the suitable transformation, x is equal to e power z. So therefore x into d by dx is equal to d by dz. So is it clear to everyone up to this?
Yes, sir.
Yeah. Now, and we will find the one more value. So right, just this. That is one more derivative. And we know that d is equal to d by dx. Let assume that dy equal to d by dz. Let us assume that d1 is equal to d by dz. So it becomes x d is equal to d1. So right. So this is the operator form. This is the operator form. This is the differential form, the general form. This is the general form. Now we are going to calculate the d square y by dx square, right? So that is, this is nothing but d by dx of dy by dx, dy by dx. So that is equal to d by dx of, already we obtained this value. What is this value? What is this value? Dy by dx.
1 by
1
z into
x
dy by
dy by dz. dy by dz. Are you following or not? Is it clear to you?
yes, sir.
Yeah, I am just substituting the first derivative value. Why? Because I already calculated this value here. Now we have to apply the u by v rule. Sorry, uv rule. So that is 1 by dy by dz into d by dx of 1 by x plus 1 by x into d by dx of dy by dz. dy by dz. So the derivative of 1 by x is what, Amma? So this is minus 1 by x square, right? Into dy by dz plus, just listen. I am changing this one as 1 by x into d by dz, d by dz into dy by dz into dz by dx. So that is, suppose it is cancelled. So this is by using the derivative rules. So I am writing this term as like this. So right. So that is d by dz into dy by dz into dz by dx. Right. So therefore this is equal to minus 1 by x square dy by dz plus, so 1 by x. So this is nothing but d square y by dz square. D square y by dz. So what is the value of dz by dx? What is the value of dz by dx? What is the value of dz by dx, ma?
1 by x.
1 by x. So this is 1 by x. This is 1 by x. So therefore d square y by dx square, that is equal to minus 1 by x square into dy by dz plus 1 by x square into d square y by dz square. D square y by, so x square is common. So therefore x square into d square y by dx square is equal to minus dy by dz plus d square y by dz square. So it is valid for x square into d square by dx square is equal to d square by dz square minus d by dz. d by dz. So that is equal to so that is equal to, write down take common as d by dz, right? So that is d by dz minus, right? So that is x square d square is equal to x square d square. This is what, Anna?
d1 into d1 minus 1.
This is d1. So d1 into d1 d1 into d1. So x d is equal to d1, x square d square is equal to d1 into d1 minus 1. So similarly, what is x cube d cube? What is
d1
x
into
cube d cube?
d1 minus 1 into d1 minus.
Yes, very good. D1 into D1 minus 1 into D1 minus 2. So here what we are doing is we are changing, right? The that is the differential equation with the constant coefficients to the differential equation with the the differential equation with variable coefficients to the differential equation with the constant coefficients. So therefore, what the summary here is, we are just replacing x d by d1, x square d square by d1 into d1 minus 1. Next, x cube d cube by d1 into d1 minus 1 into d2 d1 minus 2. So we already discussed the proof. So it is very important thing. So first we will attend one problem. So that is a simple one for finding the So write down the problem. Solve x square into d square y by dx square minus x into dy by dx plus y is equal. So this is the problem. Simple one. X square into d square y by dx square minus x into dy by dx plus y is equal to 0. So what is the solution? What is the operator form? X square d square minus xd plus 1 into y is equal to 0. So this is of the form, sorry, f of xd is equal to xd into y is equal to 0. xd into y is equal to 0. So that means that it is a Cauchy Euler equation. It is a Cauchy Euler equation. It is a Cauchy Euler equation. So for Cauchy Euler equation, we have to take the transformation x is equal to e power z and z is equal to log x. Z is equal to log x. Right? So now and what is xd? xd is equal to what, ma? Replaced by d1. So some authors may use the theta. So you can also use the theta. Theta is nothing but d by dz. But here I am taking d1 is d by dz. Next, what is x square d square? d1 into
D1
d1.
into D1 minus.
Just replace in the given equation. It becomes d1 into d1 minus 1 minus d1 plus 1 into y is equal to 0. Y is equal to 0. So this is d1 square minus d1 plus 1 into y is equal to 0. So it is a differential equation with the constant coefficients. Initially, the given differential equation is a variable coefficients, right? So we are making that into constant coefficients. Now we can simplify this one. This is d1 square minus 2d1 plus 1 into y is equal to 0. The auxiliary equation is m square minus 2m plus 1 is equal to 0. What are the roots? M is equal to 1 comma 1. M is equal to 1 comma 1. So complementary solution is equal to, the roots are repeated. So c1 plus c2 dash into e power dash. c1 plus c2 into dash. ఏంటమ్మది? c1 plus c2 into root is repeated 2 times. c1 plus c2 into, please చెప్పండి.
C1 plus C2 into e power z.
c1 plus c2 x ఆ z ఆ అది అడుగుతున్నా. సాగే చెప్పమ్మా. c1 plus c2 into
It's
z or x. Slavia, please tell me. So here d1 related to z, so that it is z into
Into e power z.
c1 plus c2. What is z? Log x. What is c2? Yes. So this is y. Right? So here what we are doing is first we are converting the variable coefficients differential equation into the constant coefficient differential equation. How we converted means, so by choosing the suitable transformation x is equal to e power z, then we get xd is equal to d1, x square d square is equal to d1 into d1 minus 1. So I just substitute the values there. So finally